Greetings, I'm Professor K, and in this short video presentation we're going to take a look at how we go about verifying the existence of the unquoted service path vulnerability on a Windows machine. First, before we get started, let's go ahead and give credit to all the different sources that I had to use to put this short video together. You're not going to be able to find everything you need on the internet with just using one source. Now, the reason I even care about putting this together is because I am preparing for a certification exam for pen testing. And on that exam, there is questions in regard to the unquoted service path vulnerability. And that's why I have taken the time to research this and to put this short lab together. And the other problem that you're going to run into when you're doing research on the internet is that a lot of times the tutorials that you're going to run into, they take you to the 99-yard line and then they just drop you off and you can't cross the finish line because the lab just falls apart right then and there. Preparing to take any certification exam will require that you spend hours and hours conducting good, hard, critical research on why the answer is correct. Not so much what the answer is, but why is that answer correct, and is it the correct answer? A lot of times you're going to find a lot of information on the internet that is just not correct. You've got to research and confirm and verify each and every answer that you find on the internet about any particular certification exam. This is the path that will take you to learning so much more about a cross-section of different subject matter and domains that you don't even think apply to what it is you're searching for, but you're going to find out that the information pool that you're wading in is only an inch deep, but yes, it is a mile wide. So there's a ton of information that you need to know, and that's the only way you're going to acquire it, is through hard, critical research. And now, on with the lab. A service whose service executable path contains spaces and is not wrapped within double quotes can lead to a vulnerability known as unquoted service path. This vulnerability allows a normal user to gain administrative access to the machine by performing privilege escalation using the local system account which is needed to launch the service executable. Let's go ahead and increase the size of my image here just a little bit. And you can see the steps that are being taken by the attacker to compromise the machine using the vulnerability for unquoted service paths. The attacker compromises a local user. Normally, they'll create a new user that is part of the built-in users group. The attacker will then identify services that are not wrapped in quotes. That's as far as this video is going to take us, and that is finding those services that are not wrapped in those double quotes. In our next video, we're going to be taking a look at actually compromising the machine and exploiting this vulnerability. So if you're thinking about taking a certification exam for pen testing, what topics might you find on that exam in regard to unquoted service path? One of the questions that you might see on a certification exam might be worded similar to the ones I'm going to show you. Question number 1, which command will allow a pen tester to test for potential unquoted service paths on a host? Well, this is the command. And now the trick to identifying this from the options that you have to choose from will be the presence of the 3 double quotes at the end of the command. That's going to be your clue that you have chosen the right answer. Question number 2. A penetration tester locates a few unquoted service paths during an engagement. Which attack can the pen tester use to test for vulnerabilities? The answer is privilege escalation attacks. So there are 3 steps to verify that a service may or may not be vulnerable to a unquoted service path vulnerability. The first step in the verification process is to find services that have a path to the executable that contains blank spaces or blank characters, and that path is not wrapped in double quotes. Now you can do this just by using the following command that you see up here inside of my command prompt. I'm not going to go over every bit of this command, and I will put the command in the description for the video. So what this command does, it looks for services that are not wrapped in double quotes, that have a blank or a space anywhere within the path that leads to the service executable. So let's go ahead and run this on my machine and let's see what it comes up with. And when I run this command on my local machine, it does find a service that is actually vulnerable to the unquoted service path vulnerability. And it tells me that it's located up inside of my program files, up inside of a subfolder called Personify, inside of another subfolder called ChromaCam, inside of another subfolder called 64, and there is an executable called PSY frame grabber service.exe. That is the executable that the API for the Windows is looking for, but it's not going to be able to go there directly. No, instead it has to start at the root folder and work its way down, asking the question, is this the location for the executable that I need to launch? And each time it's going to be told no, go on to the next folder because you didn't find it here, keep on going until finally you get into the subfolder marked 64, and that is where you'll find the executable. If the service had been wrapped in double quotes, then the Windows API would have treated this as a string, and it would have said that, hey, this is exactly where I need to go, and I don't need to look anywhere else on the machine but here to find this executable to start the service. So let me give you a visual. So I'm going to go down here and I'm going to type in the search services, and I'm going to go ahead and launch my services application. And we're going to find this particular service that is vulnerable to the unquoted service path vulnerability. And if we scroll down through my services, we can locate it right here. It is called Personify Frame Transformer. That is the name of the service. Now I'll go ahead and I'll double click it. And here you can see that the path to the executable is not wrapped in double quotes. This is the path starting here at the root, which is C:, and going all the way to the end where we have the PSY frame grabber service.exe. That entire path should be wrapped in double quotes, and the path does contain blank spaces. Let's go ahead and close this out. And what we're going to do next is we're going to actually find a service, a third-party service, where the executable path is actually wrapped in double quotes, so I can show you what the difference is. So if we scroll back up, you can see that we have another service, third party, and this is for my commercial VPN service that I have running on my Windows 10 machine. It's called Hotspot Shield Service, and there's the version number. And it's also running underneath the local system account. Now, if I go ahead and double click this, you'll see that the path for the service executable is actually wrapped in double quotes. That again tells the API you don't have to search for this executable. It's right here, and this is the path, and this is where you're going to find it. So let's scroll on back down here to my Personify Frame Transformer service. And so the next thing we need to do is verify the identity and the level of privilege the service is running under. And if we just look over here to the right, you'll see that it's running under the local system account. When a normal user logs onto their machine in the morning, they need to be able to launch certain services. That requires that they have writable access to that service just as the system or the local system account does. If that's not the case, then their services will not start. And this is again why this is such a vulnerability. And so the third and the final thing that we need to verify is whether or not the built-in users group has the permission to launch the executable once it is found. Folder permissions can be identified using a Windows built-in tool called iCackles. iCackles stands for Integrity, Control Access, Control List. This tool has been around for a long time, and we can actually use it to see who has what type of permissions on any folder up inside of our Windows operating system. In this case, I want to see what the permissions are for the built-in users group. And in particular, what permissions do they have for accessing and control of the Personify subfolder for this particular service executable. Now you're probably wondering, why is he not checking for every folder in the path to the service executable? That is because that any permissions that are placed at the root of the executable will be inherited by all the subfolders all the way down the line until it reaches the actual executable itself. So whatever permissions that the built-in users group has inside of the personify folder, those will be the same permissions that they have in the subfolder marked 64. Let's go ahead and run our command here and see exactly what permissions the default built-in users group has. And so we look inside of here and we can see all the different permissions that are being assigned to all the different default groups and users, if there are any present inside of the personify folder. Now the one that we're going to be concerned with is the built-in users. That's right here. See right there. So we learn that the built-in users has all the permissions. They have read, write, they can traverse directories, they can launch executables, whatever they want to do, they can do it starting at the root of our service executable path. So to help make this crystal clear, let's go ahead and connect the dots just a little bit more. And to do this, we're going to go up inside of that folder, that root folder called personify. So I've opened up my C drive. I've opened up the programs, the 86 folder. Up inside of that folder, I have another folder called personify. Now if I right click on this and I go to properties, and I'm going to click on the security tab, you'll see all the different users and groups that have permission to access this particular folder. And if we scroll down here just a little bit, you'll see that the users are right here and that they have read and execute, list folder contents, and they can read. So read and execute is going to allow them to launch any executable along this service executable path, regardless of what folder or subfolder the executable is located in. Let's go ahead and close out of this. So as a pen tester or as an attacker, if I can gain access to the target machine, either physically or remotely, then I can bring up a command prompt or a shell, and I can launch this command that I showed you earlier. And now I can look for any services that may be vulnerable to the unquoted service path vulnerability. Now there's a couple of different ways that the attacker or the pen tester can proceed. They can go ahead and try to replace the known good, that is to say the executable PSY frame grabber service.exe, with a piece of code that is using the same name, but it's actually a piece of malware that is going to throw a reverse shell back to the pen tester or to the attacker when the machine starts up. Now regardless if the machine starts up or is restarted or whatever the case may be, as long as that user has access and can launch that particular executable because of their permissions, then any default user who gets on the machine, starts it up, will be throwing that reverse shell back to the pen tester or to the attacker. Now the other way is for the pen tester or for the attacker to create a bogus service, and they can launch that service the same way as a normal service would launch, but the service is actually going to throw a reverse shell back to the pen tester or to the attacker. Now that process of uploading a piece of malware to the machine and actually having it run as a service is much harder than it seems, because Windows Defender does a very good job of identifying that particular signature for that particular type of reverse shell that you're trying to launch with your bogus service. So it does take a lot more than just creating that malware and just loading it up to the service and restarting the machine or the service and creating that reverse shell. And we're going to see that in my next video. So as a pen tester, you've identified the vulnerable services to the unquoted service path vulnerability. Now, how are you going to explain how to mitigate this on your report? Well, there are three different things that you can do to help mitigate this type of vulnerability. First, ensure that any service binary with a space in its path is wrapped in quotes. Secondly, restrict file and directory permissions. restrict access by setting directory and file permissions that are not specific to users or privileged accounts. Number 3, execution prevention. Block code execution on a system through application control and script blocking. All that sounds really good, especially when you're a pen tester and you write it up on your report. Problem is, you start messing with the permissions and the access to certain executables, especially services, and you don't know what you're doing, you're going to turn that machine into a brick real quick. I suggest that you do not play around with any permissions for any user account unless you absolutely know what you're doing. I'm Professor K. Thanks for watching, and I'll see you in my next video.